We're doing pre-calculus, page 338, problem number 21. So this says, from a point 50 feet in front of a church, the angles of elevation to the base of the steeple and the top of the steeple are 35 degrees and 47 degrees 40 minutes, respectively. And they ask us to do three things. They ask us to draw right triangles that give a visual representation of the problem and label the known and unknown quantities. In part B, they ask us to use a trigonometric function to write an equation involving the unknown quantity. And part C, which is really what we're after here, part C, find the height of the steeple. We want to know how high the steeple is. All right, that's number 21. Okay, so the first thing that we need to do is draw a picture. So what are we going to draw a picture of? We've got a church, and this church has a steeple. And we're standing 50 feet in front of the church. So we've got a church. There's a church. We're just looking at it from the side. I'm not going to try and draw a good church. And then here's our steeple. So it's got a nice high pointy steeple on it. And maybe here's the roof of the church back here. All right, that's our steeple. That's the high part on a church. And we're standing, it says 50 feet in front of the church. So we're standing over here somewhere. This is us. Let's just have ourselves be a dot because it really is about this is our point of view. So, you know, this is where we're standing and that's our point of view. All right. Now, let's put some numbers on here. So we've drawn a picture. And, you know, always the question is, where is the right angle? Where's the right angle? Now, we're interested in the top of the steeple and the bottom of the steeple. So we probably have our right triangle right here like this. But let's look at what we've got first. So they tell us that we're 50 feet in front of the church. So that means this distance to the front is 50. Now, I don't want to complicate matters by the fact that the steeple actually leans in a little bit. So what I'll do is I'll just say, let's have the front of the church be directly under that top of the steeple. And then this is 50 feet from me to that church. All right. And then it says the angle of elevation to the base of the steeple. Well, where's the base of the steeple? This is the base of the steeple. It's the bottom of the steeple. And then the top of the steeple up here. This is the top of the steeple. So it gives two angles of elevation. So our angles of elevation, if you recall, angle of elevation is from horizontal. So if I'm here on the ground and I'm looking up at something, then my angle of elevation is here. But we've got two angles of elevation. One angle of elevation, it says, is to the base of the steeple. So here's from me to the base of the steeple. Then there's another angle of elevation, the top of the steeple. So that means from me to the top of the steeple. So here's our second angle of elevation. Oops, I made that a little off, but there we go. So this is our second angle of elevation. Let's give that one a little bit different color. So this is our second angle of elevation. Now, they use this word respectively. That means the first one they named goes with the first thing and the second one goes with the second thing. So the 35 degrees goes with the base of the steeple. So that's the 35 degrees is this base of the steeple. And it says that the 47 degrees 40 minutes, that's to the top of the steeple. So the 47 degrees 40 minutes, that's to the top of the steeple. And we have to remember that's this whole angle right here. So we need a strategy for this problem because we only want, if you look at what they ask for, the height of the steeple. We want the height of the steeple. Well, the height of the steeple is just this, from here to here. That's what we're trying to find out right there. That's our x. But the problem is this does not form a right triangle. We need a right triangle, otherwise our trig functions don't work. So what we're going to do is we're going to draw a right triangle that goes all the way to the bottom. And here's a right triangle. Now what we can do then, if we want just this little part here, is we can find the height of this whole thing here. And let's call the height of everything here, let's call that y. We can make up our own variable to stand for things. And then I can look at this distance from the ground to the base of the steeple, and we'll call this distance just from here to here, let's call that Z. So now I've got the height from the ground to the top of the steeple, and I'm calling that Y. I've got the height of the steeple, which I'm just calling X, and I've got the distance from the ground to the base of the steeple, and we're calling that Z. So the strategy we're going to use is to say, I can use this big triangle to find Y, I can use this little triangle to find Z, and then if I do Y minus Z, it will give me X. So Y minus Z will give me the X that I'm looking for. So that says that if I take this whole height here, that's the Y, and I just subtract out this part, Z, then what's left is the height of the steeple. So we had to build these extra triangles. We had to really come up with 2 triangles to solve the problem. So now we need to set up, what will really help, I think, is we're going to separate these 2 triangles out. So first I'm going to look at the little triangle. So the little triangle has 35 degrees, and this side of it is Z, and this distance down here is 50 feet. That's the little triangle. And then the big triangle, that has the 47 degrees 40 minutes, and the height here, the height of that big triangle is that whole distance Y. Now I can find Z and I can find Y, and I can subtract them to get X. This 50 feet is also the base of this rectangle, this triangle, 50 feet. All right, so now we're going to solve for this one. So we have to look and see what we've got. Our given side is adjacent to the 35 degrees. Our unknown side is opposite to the 35 degrees. So now I have to say which function has adjacent and opposite in it. So I have to remember, and I remember that tangent theta is equal to opposite over adjacent. So now I can fill in the information from this triangle. My theta, my angle, is the 35 degrees. So tangent of 35 degrees is equal to my opposite side, which is the Z that I'm trying to find out, over the adjacent, which is 50. Now I'm going to solve this with the variables on the top, so I just have to multiply both sides times 50. So I'll go times 50 and times 50. And then I will have 50 tangent of 35 degrees equals Z. And now I'm ready to put this in my calculator and calculate it. So I'll get my calculator and we'll clear it. I want to check that I'm in degrees, and it says right there DEG, so I'm in degrees. So I'm going to go 50, 10, 35, enter, and it tells me it's 35.01. So let's just round that off to a whole number and call it 35. So 35 is equal to Z. Now that's a coincidence that the tangent of 35 times 50 happens to be also 35. 50 times the tangent of 35. We're checking to make sure we're in degrees. It says DEG, so we're in degrees. If that said RAD, I'd have to go a shift setup and change it. But it says degrees, that's what I want. And I got 50, 10, 35, and I just press execute. And it tells me 35.01. So I'm just calling it 35. Next triangle. Now this 35, that's our Z, which was this, just this part right here. So that's our 35 is equal to Z. Now we're going to find this height Y using this triangle. So again, we have to determine which sides we have. The Y is opposite to the given angle, so this is an opposite side. The 50 is right next to the angle, so that's an adjacent side. And you know what's interesting about the way we write our notation? This little mark here means minutes. And in fact, 1 minute is equal to 1/60th of a second. That's different from this mark here, which means a foot, which is 12 inches. So when we have a distance, we put 1 mark, that means feet, that's 12 inches. But when we have an angle and we put a mark like that, that means 1 minute, that's 1/60th of a degree, I'm sorry. It's 1/60th of a degree. All right, so we know we have opposite, adjacent. So again, we have to think what function has opposite and adjacent, and it's again tangent. Tangent theta is equal to opposite over adjacent. The tangent of the angle I want is this 47 degrees, 40 minutes. So tangent of 47 degrees, 40 minutes is equal to the opposite, which is y, over the adjacent, which is 50. Now we need to solve this. I'm going to get the y by itself. Again, we're going to multiply both sides by 50. So times 50 times 50. And now I'm going to have 50 tangent 47 degrees 40 minutes equals y. So now we have to go to the calculator and figure out 50 tan 47 degrees 40 minutes. But in order to do that, we need to be able to deal with this 40 minutes. So this 40 minutes, since a minute is a 60th of a degree, we're going to have that 40 minutes be 40 over 60. And we're going to add that to our 47. So our 50 tangent 47 degrees 40 minutes is equal to 50 tangent 47 plus 40 divided by 60. And that's how we're going to put that into the calculator. So now we're ready to put it into the calculator. And this time we're going to go 50 tangent. And now I'm going to put, I need parentheses now. To get this plus sign in here, I must have parentheses. So I'm going to put a parenthesis there. And then I'm going to go 47 plus 40 over 60, 40 over 60. And now I have to close parentheses. So I close my parentheses. Now I'm ready to go. EXE, let's execute. I get 54.885. So 54.885, that's my value for y. So, since that's y, the height here, now all I have to do is go back to my original strategy, y minus z equals x. So my y is the 54.885 minus my z, which is 35. And that is going to equal the height of the steeple. Now I could go for a calculator on that, but I think I can do 54 minus 35. Isn't that about 19? I think it is 19. And then we're going to keep our 0.885. Feet. Now, this is our answer. They haven't told us what to round to, but if we want to be reasonable, we can look at the way they gave us the information. They said this was 50 feet from here to here. So if we say 19.885 feet, we're probably expressing more accuracy than we have a right to. So probably we should just say that steeple is 20 feet high. So I've rounded to the nearest whole number. For those of you guys who are studying significant figures, I also kept the one significant figure from here, and I kept that there. But that's not always what we want to do for these problems. So the height of the steeple is 20. Does your answer make sense? Does about 55 feet seem a reasonable height to the top of a steeple? It seems so. Does 35 feet seem like a reasonable height for the top of a church? Sure it does. Is 20 feet a reasonable height for a steeple? I should say so. If I got 2,000 feet, I would think my steeple is too big. If I got 0.002 feet, I would think my steeple is too small. So I see a number like 20 feet. That looks like a reasonable answer. It's always important to ask yourself, does your answer make sense?